So now, for this section, we're trying to solve the logarithmic equations. They say, that's what I'm telling you, this is like a golden rule. Every time when you have the same base, what does that mean? X equal y. So I'm gonna focus, if I get the same base, that means I have the same or equal exponents. If I have equal bases, that means I have equal exponents. Yes. I think there's another rule. Because with the logs should be worked together. So if I have log the base b to the x equal log to the base b to the y, that means x equal y. Is that okay? So we have two rules. Let's extend that. If you have ln x equal ln y, that means x equal y. You get the idea? So every time when I have ln number equal ln number, that means the number should be equals. We're gonna start with this one and then practice on the rest. Now the first example, they're telling you find what? 5. Okay, keep this full. 5 to the exponent x minus 1 equal 125. Now I'm gonna ask you, can you see a log? With the example, can you see the log? No, that means I can't use these two rules. I have to focus on the first rule. This is called, this one is called exponential equations. Why? Why it's called exponential equations? Why? What do you think? Why? Because the exponent is a variable. It has variable. Now that means I have to focus on using this one. How I'm going to get two equal bases? By the way, this one work on both sides.
Wasn't there like a rule that where you could take the 5 and then you could put it on the other side?
Which one? Take this one?
Was it that one? So
this one?
Yeah, but I think it's in the log, right?
Not now. I know what you're talking about, but not now. So now, how I'm going to, because we're going to use it, we have to use a certain example.
Okay.
How are we going to use this rule? I have to focus to get two equal bases, because it's impossible to get two equal exponents. Because I have variable here. I don't know how much the value of x. So how I'm going to get two equal bases? Think about that a little bit. 5, I can't factor the 5. What about 125? Can I factor the 125, which is what?
25 times 5.
Which is what?
25 times 5.
No, I need to factor it more in a way I can write down the same base.
5 to the
5 cubed. 5 cubed is 5 times 5 times 5. So I can write down, that's why you have to think in this way. I have to factor this one to get the same base with the other side. So 5 cubed, which is 125, and here is x minus 1. Now, do I have equal bases? So can I, if I have two equal bases, what's that mean? The exponents are equal. That means it's a 3x minus 1 equal what? 3. Now, can I solve this one? It's a linear. Move the 1. So 3x equal 3 plus 1, 4. Then divide both sides by 3. So how much the value of x?
3.
Now, how are we going to make sure this is the right? You can use the calculator. Plug in 4 over 3 here. 3 times 4 over 3. It's going to be 4. 4 minus 1. 4 minus 1. 3. That means it's 5 cubed. Is that equal to 125? Yes. You got it? So that's how you're going to solve exponential equations. You have to think out of the box. Number 2, what did I tell you? Solve 1/4 equal what? A to the power x. Now I need you to think in a way, how are we gonna get 2 equal bases? First of all, the problem we have a fraction. There's a way to
You're gonna turn the 8 into a fraction?
how? Okay, that's right. Can you move the 4 to the top? How much the exponent for the 4? Now here. Right down here. Remember that with the exponents, if we have a number over positive exponents, right? I can say it's the number with negative exponents.
Yeah.
I can do that. How much the exponent for the 4? 1. So if I move it to the top, it's going to be what? 4 to the negative 1 equal 8x. Now, yes, the bases, now I have 2 bases and they are on the same level, not a fraction with a number. Now, what's the next step I can do to make I have 2 equal bases?
You can make it 2 to the second power. And then
Okay, so here on this side, I can 2 squared, and here is negative 1, right? Here,
2 to the third power.
2 to the third power, which is 2 times 2 times 2 is going to be 8. So I can say here it's 2 cubed, and here is the x. Now, can I multiply these two numbers? The exponents? 2 negative 2 equal what? 2 to the 3x. Is that right? Yes or no? Now I have 2 equal bases or no? 2 equal bases, that's be negative 2 equal what? 3x. Now divide by 3. So how much the value of x? Negative 2/3. Is that okay? Can we do the same thing with the next one? So the goal here, how much you got?
-1.
Let's see.
I'm doing it too much in a hurry.
Let's see, okay. Could it be -1? I don't know. I'm sure it's not -1. Let's see. So 8, you're gonna say what? 2 cubed, right? And everything to the power x plus 3. Equal 4, 2 squared, and everything to the 5 minus 2x. When you multiply the exponents, you have to distribute. So 2, 3 times x, 3x. 3 times 3, 9. Okay? Equal 2 times 5 minus 2 times 2, 4x. 2 equal bases, that means I have equal exponents. 3x plus 9 equal 10 minus 4x. What's the wrong thing? Move the 4 here. Oh, you see? So you're gonna add 4. If you want to move this one here, it's gonna be the same. But when you move it, you're gonna add 4, so it's going to be what? 3x plus 4x equal 10 minus 9. That means 7x equal what?
Yeah.
You got it?
I did it the other way. I subtract. Oh, that's what I did.
I'm telling you, when you solve it and you get the wrong answer, that's fine. That's the first steps to solve it.
Instead of adding, I subtracted the 4.
So you have to be careful.
Simple mistakes.
Next one. Solve 2 to the x. You see, that's the second type of equations. Example 4. Okay? You see now the first type? The whole thing we did here is first type to use 2 equal bases. Now the second type, 2 to the power x equals 7. Can we get 2 equal bases? If we get 2 equal bases, and I'll give you 100 on the test. Sometimes it's not a prime number. Sometimes it's just like we have here 10. I can write down the 10 with number with exponents, so I can get the same basis. You get the idea? So think about that. How I'm gonna solve this one. By the way, all the rules here. The what? What?
Logarithmic.
The logarithm. The first rule, if we have just like these numbers, you see, I'm gonna use equal bases, equal exponents. With the second one, if I can't find equal bases, I'm gonna go jump to the next one or the third one. Both is going to be right. I always use this one, so I'm not gonna do the log. But if you want to use the log, it's the same result. Okay. So now I can't use the first rule. I'm gonna use the ln. But in a way, I'm going to consider I have this side. You got it? So I'm gonna go back, go back to the other side. So I'm going to consider by using the ln x equal ln y. This is the rule when x equal y. I have x equal y. This is the x in general, not I'm talking about this variable. This is the x and this is the y. X, y, that's mean I can use ln to the both sides. So I'm gonna say ln 2 to the x equal what? Ln to the 7. Is that okay?
Okay.
Now what's the next step? My goal is to find the value of x. That's why it's equations. So the goal is to find what? How much x? Now tell me what's the next step so I can solve it.
The x in front of the.
That's the good one. So you're just gonna move the x where? Here by using one of the natural log properties. So it's going to be x ln 2 equal what? Ln 7. Now our goal is to find what? The value of x. What's the last step? What's the operation between x and the ln? Multiply. So if I need to keep the x by itself, what I'm going to do? I'm gonna make it easier. Look here. If we have 2x equal 4, I need to keep the x by itself. What I'm going to do?
Put the x on the other
Divide
side.
by 2, right? Same thing here. I need to keep the x here. I'm going to divide by what? So divide both sides by ln 2. This is 1, so x is going to be what? Ln 7 over. That's it. Ln 7 and ln 2, you can find it. You can use the calculator and just go ahead and plug in ln 7, divide by ln 2. And be careful when you're using the calculator. Here, wait. When you're using calculator, you're gonna say, okay, you're gonna hit the ln function, it's going to be ln, right? And open parentheses. You're gonna put 7. You have to close the parentheses.
Okay.
If you're not closing the parentheses and you hit the division, it's going to be wrong. Because it's going to be divide by what? By ln 2. It's going to be like this. You're dividing 7 by ln 2, and the result you're taking the ln, which is wrong. So in the calculator, you're going to say ln 7, close the parentheses, divide by ln 2, close the parentheses. Is that okay? And here's another thing. Do not say I'm going to cancel the ln with the ln, because I'm going to be so mad. Okay? So be careful with this one. But you get the idea, right? So that's, if they ask you about the exact solution, you're going to put this one.
That's
They
it.
ask you on Alex, what's the exact solution? This one, the exact solution. If not, because when you plug in the calculator, what's going to happen? It's going to give you a decimal number. They're going to ask you to round it. When you round the number, it's not going to be exact solution. It's going to be approximate solution. Can I use the first rule? Log base equal, if I have 2 equal bases, that means I have 2 equal exponents. I can't, and It's impossible because you have 0, 0.7, 0, 0.2, and here's a 3. I can't find the same base. So I'm going to think about using the log or the len. Log or len is going to be the same result. Is that okay? So I'm going to consider everything here is x and everything here is y. That's mean I can take len, this number, 3.-0.02x equal len 0.07. Now what's the next step?
Exponent for the lid.
Here. So it's going to be negative 0.02x len 3 equal what? Now tell me how we're going to do the next step. I need to keep the x by itself.
Divide it,
Divided by what?
len 3.
What about this number?
You wait to this another step.
No. Divide. What's the operation between here? Here. So divide by everything here except the x. By negative 0.02 len 3. Okay? Because negative 0.02 len 3. Was this one cancel with this one? Len 3 cancel with len 3. What's the left? Just the x by itself. And again, when you plug in here, be careful. You see what happened here? You have to be careful. Are you going to plug in the calculator? You don't want to say len 0.07 divide by what? I know you're going to do mistakes.
Len 3 and then the exponent on top.
There's no exponents. No, you don't have. It's going to be good. It's going to be right. If you want, it's going to be right. Believe me. If you want to move this one here, it's going to be totally right. If you move the whole number here,
Or you can just leave it like that.
it's going to be right. Like in the calculator, if you want to plug in the whole thing here, you have to be careful by opening parentheses. Negative 0.02, then to the 3. You're going to type it like this. And as Carlos says, if you move the exponents here, also is going to be right. But it's fine. I'm going to give you 100. But I'm going to consider everything here is what? X. So the problem is look like 4 plus what? 3x equal 11, right? How are you going to solve like this problem?
4 divided by 3.
Oh, wait. First of all, what's the first step?
Subtract 4.
Okay, can I do the same thing here? So if I say minus 4, cancel here, what's the left? Equal what?
7.
7. That's what I did here. Minus 4, right? The left is 3x equal 7. Now, what's the next step if you need to solve this one? Divide by 3. Can I do the same thing here? So if you say divide by 3, what's the left? E to the 2x equal what? 7 over 3. Yes or no? Now, can I use this rule? Don't worry about the E. No, the E is going to cancel by itself. Can I use, if I x equal y, can take it into both sides? The same thing here. So if I say this is x and this is y, that means I can take len e to the 2x equal what? Len 7 over 3. Is that okay? Now who's going to tell me what's len to the e?
What?
The whole thing here is what? That means what's the left? Equal. Can I find the value of x? So no. X is going to be what? Len
7 over 3 divided by 3.